All right, I think we're ready to start. Hello, everyone. On this sunny late summer afternoon. I'm sorry that you guys have to be inside. It's beautiful weather, but I kind of have the feeling that the committee will not have to deliberate all that long, so we'll make this speedy. I'm really pleased to welcome everyone for the defense of the doctoral thesis by Harin Lee. Welcome to the committee members. Gesa Hartwigsen and Martin Hebert are today with us. The other members are excused. And welcome to the audience as well. And I hope you can give a lot of moral support. So this thesis is a work of several years, of course. We officially started, so the faculty started or opened the proceedings here on the 2nd of June. And we received the two written examinations or two written evaluations on the 11th and the 25th of July. Both of the reviewers recommend that the defense move forward, and thus we can be here today. The way this works is that Harin is going to give a half-hour talk showing us how he spent his time, scientifically speaking, and then there is a 30 to 45-minute question period. The committee starts, but then the floor is also open to questions from the audience. So whoever wants to end the friendship with Harin immediately can think of a very difficult question now. Yeah, that's pretty much it. So a few words to Harin. Harin was born in South Korea, 94, if I remember, something like that. Oh, I'm looking at your, but this is what I remember. You did your bachelor's and your master's at Goldsmith in the UK. Mm-hmm. And I remember you joining for the Impress selection round. Was it in 2000?
2020, yes.
2020, exactly.
Yes.
And I very much remember you were the last one to perform or to be interviewed. And I remember the committee going, wow, finally, wow, we have a clear winner. It was like no discussion after that. So you really won that with a landslide victory and got the scholarship of the Impress. And your contract started at this point. You also came with a already really well-established network of international collaborators that you really drew upon during these 4 years, and also with a very clear idea of what you wanted to do. I think I've never have advised so little. You really told me what you wanted to do, and you went ahead and did it. The thesis comprises 7 papers, so that's really some excellent output there. Several of them published in very highly respected journals. Yeah, what else is there to say? You already have secured your next career step. You'll be joining Cambridge University on a tenure track fellowship. So that's, I guess, pretty much not as high as you can. Not quite, but yeah, it's on the way. So I think that's you're off. Let's say you're off to a good start. Well, what else can I say? I think I will start with. We should start with your presentation. I will then read a little bit from the written reviews, and then we do our question round, and then the committee deliberates. Voilà, Harin, over to you.
Thank you very much. Okay, so I've got this sophisticated system that tracks your face. Okay, thanks everyone for coming and everyone who's joining online. So we live in a very highly connected world where the majority of the population now has access to the internet, and which brings access to the global network of human interactions. And global food franchises like KFC has now reached every corner of the world, impacting our diet. And in the same way, music also have become ever more globalized, that there would probably be thousands of Taylor Swift that's being aired in this hour. And for those who might wonder which country favors one or the other. So then in this world with everyone having access to the internet and mobile phones, one might ask, aren't we now all kind of listening to the same kind of music? Then my thesis would argue that just like KFC didn't completely replace the local cuisines of the world, music is something that is stable and to a large extent that maintains the cultural signature of the acoustics. And in fact, my analysis shows that only 5% of the mega popular artists, if you account for the artists who are popular in more than 10 countries, in a total set of 58 countries, that's a pretty small percentage if you think about the 95%. The rest is locally niche artists. And just to give you an idea of how diverse the music is and what kind of music is popular in different parts of the world, I selected a few examples, and then we're going to start with Turkey. South Korea. South Africa. And Bolivia. Now then the question is, how can we capture this richness? So the traditional methods on doing cross-cultural music has always faced this kind of particular dilemma, in that there are two buttons to press. Is that one, you could press the button to rely on music notations, but then you inevitably face the challenge of using a Western-centric metric to analyze music, and therefore it might not generalize to other cultural musical cultures and missing the cultural nuances. You could instead press the other button and look for doing qualitative evaluation by inviting ethnomusicologists and doing an in-depth review of music. But then this becomes very resource intensive and therefore difficult to scale. So throughout my PhD, it was all about addressing these two challenges and to develop new methods and tools in order to understand global variability of music in a meaningful way. And at the same time, trying to reveal the mechanisms that underlie this constantly evolving musical culture. So then one approach that I took was to leverage big music data from the real world. And in several studies that I conducted, I was particularly interested in looking at how much of our living environment and the demographics influence on the diversity of music the very people listen to. And one concrete hypothesis that I tested is looking at how the size of the population matters on the resulting diversity. And previous research has indicated that large populations and large groups in general has this advantage of accumulating cultural knowledge and therefore having more chance of technological innovations, resulting in more diverse outcomes. And I wanted to test out these theories in the real world, where I had the great opportunity during my internship at Thesis Research in Paris, where I had the opportunity to track the music listening patterns of over 2.5 million users across 3 countries. And particularly looking at where each of the users live and looking at the size of these cities and towns, and also estimating their demographics, such as income, education, and their social networks. And all of this, I related them to their music listening pattern of the entire 1 month music by looking at their entire 1 month music listening history. And then I measured the diversity of music in different places in 2 different ways. One, by looking at, in a given region, among the residents of this place, how much their musical taste align with each other. So looking at the between individual level. And at the same time, for each of these individuals, how much do they individually explore the music? So their musical breadth that they explore. That some might have a very focused taste that they listen to only one particular genre, while some might have more diverse consumption taste with having an eclectic musical taste. So first, looking at the between individual diversity and the direct influence of population size, we find very strong positive correlation, meaning that the larger places that you live, capital cities like Paris and Berlin, people tend to have more distinct musical tastes to one another. But then you need to also consider the fact that urban areas and rural areas really differ in their demographics, like education, income, age, population, and so forth. So I also consider all these different confounding factors, model their interactions through directed acrylic graphs, and try to estimate the direct influence of population size on the diversity. And after you do that, you see this substantial reduction in the effect. And importantly, particularly in the largest population quantile, meaning that the diversity arising in the capital cities is mainly coming from the demographics. But then at the same time, it doesn't completely kill this linear trend, suggesting that population size itself is nurturing some form of diversity after controlling for all of this. Now, if you look at the within individual diversity, the breadth of exploration that one goes through, we see, again, a very strong positive correlation when you look at the dashed gray lines. But then after the control, there's a substantial reduction, but at the same time, you see slightly different pattern. And you see that after medium-sized population, it kind of plateaus, meaning that once the city sort of reaches a certain size, it might provide enough infrastructure for the individuals to explore. And after that, it's more about this extra push, mainly comes from the demographics, like your income and education and so forth. And the additional findings that we have for this is that this breadth of musical taste changes throughout the course of life. And that in your early 20s, it rapidly expands where you're discovering new music, new genres. And in your early 30s, it sort of reaches its peak where you have your maximal exploration. And then it declines gradually where as you age, you become more curated in your musical listening choices. So far, we looked at the consumption preferences that is arising from different places. But what about the musical content itself? So in order to look at that, we gathered more than 28,000 songs from a balanced set of 58 countries. We passed this through a deep learning model, which essentially allows us to pull out the vocal and the drum aspects of the music. And then we developed a sort of in-house technique that allows us to extract the features, the melodic features and the rhythmic features of the song. And most importantly, this method doesn't have any assumptions about the musical system and just simply relies on a set of heuristics. So once we do that, what we get is this probabilistic representation that is continuous, that is capturing the core characteristics of the melody and rhythm. So having established this, we can use this representations in order to understand the entropy of the diversity of melody that exists in a given country and list them by the most diverse to the least diverse. But then at the same time, we can do the same thing for rhythm. Then one would intuitively think that in a country where you have a lot of diverse melodies, you should also have diverse rhythms. But then it turns out that these two components, these two diversities, doesn't correlate at all. And that was very surprising to us. And the story becomes more interesting when you start looking at how these two components independently interact with different kind of demographics, such that countries that have more mix of ethnicities tend to have more rhythmic diversity, whereas countries with more religious mix tend to have more melodic diversity. So these kind of interactions, independent interactions that we find, kind of challenges the previous works that have mainly looked at cultural artifacts like music and literature in this sort of holistic thing that uniformly moves and evolves. But instead, we're finding that different building blocks, even from the same cultural artifact, might interact with different layers of demographics. So far, we looked at the diversity arising in different places, but music also, like a contagious virus, it can also propagate through space and time. And we wanted to also understand this diffusion process on how musical trends essentially spreads. And to do that, we utilized network analysis models in order to basically look at the cascades of events that happens for each of the songs, that the song becomes popular in city A, and then maybe next week it gets to city B, and then city D and city D, C and D and so forth. Then we apply this model to the monitoring that we've been doing for 1,400 cities around the world, what kind of music they've been listening. And then we're able to infer this global network of diffusion, how the musical trends are diffusing around the world. And we are particularly interested in understanding the structure of this network and whether we can even use this structure to identify what kind of evolutionary processes might happen in a particular place. And one specific case study for that is that at a certain point in time, we see this radical change in one part of the network, and that comes from the post-Soviet cluster. And this cluster consists of the cities that once belonged to the Soviet Union. And normally they would sort of intermingle together in this one cluster. And at one point in time, we see this dramatic change where the cluster fragments and splits apart. And during this time, it coincided with the Russian invasion of Ukraine. So it kind of led us to look at causally how the acute societal events that's happening in the real world might transform the musical culture. And by more deeply looking at the content of the music, we find that this fragmentation of the network largely stems from the fact that the kind of music that they're listening to is changing. Within Ukraine, we now suddenly, after the onset of the invasion, we see this dramatic rise in the rise of local Ukrainian music that is completely replacing the Russian songs that was the majority. And other post-Soviet nations, we find this, interestingly, even within Russia, this uniform declining pattern that might be indicative of this anti-Russian sentiment coming from the invasion. And surprisingly, even within Belarus, which is technically politically aligned with Russia, we see a small uptick in this consumption of Ukrainian music that might be indicative of this undercurrents of resistance in these countries. And this change, the cultural transformation, it happened really rapidly, that within a few weeks, there was this complete replacement. And if you look at the content of the lyrics, the word cloud itself is self-explanatory in how the music have changed. And this is one example in which we can look at in real time by monitoring the cultural changes processes that's happening by relating them to a real world event that's happening in the society. And with the spatial granularity that we have, we could even detect more intricate nuances that happens even within countries, where we see that this rise that we saw at the country level of Ukrainian music, it was mainly stemming from the west of Ukraine, whereas the east of Ukraine, there wasn't much change, or there was only a very small increase. That shows this, that almost brings to the surface of this underlying division that might already exist within the country. And within Russia, the pattern is also very interpretable in that the places with the most decline of the Russian music came specifically from places that constitutes mainly from ethnic minority populations, who might potentially have a similar historical past that their cultural reactions might have been more amplified. So other big data projects that I've been involved is to also look at longitudinal changes in weather patterns and relating that to acoustic features. And I've also collected 2 large data sets, one called Global Pop that looks at the musical trends since the 1960s around the world. And there's this ongoing radio project that monitors 10,000 radio stations around the world, 24/7. It's been happening for 3 years now. That results in almost 80 terabytes of audio data. So my second approach to understanding global variability was to look at the cognitive preferences of people by utilizing experimental paradigms. So our life is full of experiences, and we make different choices, such as what kind of clothes we would wear that day, or what kind of scenery is appealing to us that we decide to worthy enough to take a photo of, or the kind of music that we listen to. And then the long-standing debate in cognitive science has been about how is our experience or our preferences shaped by the cultural environment that we live in, where it would be the cultural learning, and that through the exposure and statistical learning, we've learned to like certain things. Or how much of it is actually innate and hard-coded in our human biology. But why isn't everything culturally learned? There's a reason to think that why certain things might be innate. For example, if we take musical chords, where you have 2 different pitches, you play them together, and then you have a chord. Certain chord sounds nice to us, so we give it the name of consonant chord. That sounds something like this. And then if you look at the amplitude spectrogram of this, you see this very evenly spread reoccurring pattern. But certain combinations of sounds aren't really nice to us, and we call them dissonance. And if you plot that again, you see this irregular pattern, and that actually also causes beating in our eardrums physically that we might find it displeasant. So then maybe there is something about the natural world, that there's physical property that would guide us to like certain things or not. So in the past, looking at this kind of aesthetical preferences, the paradigms have mainly relied on discrete categorized stimuli, where the researchers mainly cherry pick certain stimuli that they think they're distinctive enough to look at the variability. But then obviously that's up to the researcher's choice, and the researcher has their own bias that comes from their cultural background as well. So what if we could not have this assumption at all and try to utilize a continuous space? A continuous space, by what I mean is that if we were to take the chord example again, that we would define a low dimensional space of pitch 1 and 2 as an X and Y. And then we randomly select a specific point in this space and play this chord to a participant and say how much you like them. Now you pick another point, play the chord, ask how much you like them. And then you do this many, many times, which basically essentially covers different areas of the space in a random way. And then now you invite the second participant that overlays on the results of the first participant. Then imagine you do this for 100 participants, then you would have many, many dots. And if you were to now interpolate across these points and smooth out the thing through kernel density estimation, you get a preference map that looks something like this, where the yellow regions are the preferred regions, whereas the purple is disliked regions. So we apply this continuous technique across 5 different modalities, resulting in being able to map the preferred regions of the spaces of shape, curvature, color combinations, musical harmony, and musical melody. And we did this across 10 countries with almost 5,000 participants. That also allowed us to look at cross-cultural differences in how this kind of preference maps would look. And for certain modalities like curvature, you find substantial cross-cultural differences where you would find in different countries a different map of these preference regions. And we extended this through our recent expedition to the Bolivian Amazon, where we tested the same paradigm with small-scale society Chimane villagers. And for them, they showed an even more radical difference, where at least within our online population that we had for the 4 countries, we saw an S-shaped preference and a mirror image of that. But this is completely missing in the Chimane population. And in fact, they generally liked a straight line instead of a curve, any curve. So this points to the fact that certain modalities in this kind of paradigm can be very powerful in understanding how much of it is a social construct or how much it could be, in a way, universal that we all like. And this paradigm initially originated from a different project where we looked at different musical timbres and how that influences perceptions of chord preference. And a similar paradigm has been used in a production context where participants sung a heard melody, where we mapped not preferred regions, but the most frequently occurring regions of the melodic space. So then when I'm doing this kind of cross-cultural research and cross-linguistic research, the major challenge that you face is the problem of lost in translation. And to overcome this challenge, I developed several methods. And lastly, I would like to talk about that. So suppose you want to play some music to participants and want to understand what kind of musical emotions exist by asking participants to provide textual descriptors. So you would listen to a music, sounds like and then traditionally, what researchers would often do is to have a predefined category of emotions and ask participants to pick which are the most suitable one. But then coming up with this category is one problem, but how much of this category even applies to other languages or generalize, it's unknown. So then you could take an alternative approach by just asking participants to just freely express what kind of emotions that they think, that they feel or perceive from the music. Then, and in their own native language. But then usually these kind of processes are very sort of resource intensive and comes up with duplicates of synonyms, online trolls that just come up with different irrelevant terms. So what if we can actually streamline this process where you have the elicitation and refinement of the terms in one single package? So in one sense, you could get the first participant to say what they think about this music. And now the second participant doesn't have to come up with the same tag again. They just need to tell us like how much they agree with the tag that is produced by the first participant. And at the same time, provide more tags if they want to describe what they think. And then the third participants now look at the response of the first and the second, and then also make its own judgments about validating these tags. And they can also flag problematic tags that shouldn't be there. So through this process, and if you do it enough iterations, that you would end up with having this high quality tags that are both rated and validated through this collective brainstorming process. So then we applied this technique across 5 different languages, where we were able to extract this rich taxonomy of musical descriptors that describe the emotions of music. And once we have that, because for each of the terms, we also have its ratings that is made by the participant across the set of songs, we could also compare the associations between the terms even across languages. That you would think that the rating patterns of the word sad across the songs would pretty much look similar to triste, sad in French. And that these profiles should pretty much align. Whereas if it was a different term, sad with nostalgie, then these patterns might not align so well. So imagine now scaling this to all 5 languages that we did and across all the terms that is embedded. And then we have this gigantic matrix of align and misalign. Then we project all of this into a joint embedding space that essentially captures the emotional space of how people describe musical emotions in different languages. And this space is highly interpretable in that a lot of the terms that are about high arousal and high valence emotions are on the grouped at the top, whereas terms that describe low arousal are grouped at the bottom. And importantly, if you start looking at specific terms, like sad again, for example, you start seeing that they're all intermingled in one particular location of this space. meaning that there is this strong consensus across languages how sadness is interpreted in music. But then you also see more culturally niche terms like appealing in Korean. And appealing here in the context of not is attractive, but you're appealing to someone, like appealing for mercy. And that kind of term would only be used in Korean to describe the emotions in music, but you wouldn't find any other linguistic equivalents in other languages. And importantly, this kind of work has also real-world implications in that when we distill this knowledge that we learned from different languages to a large language model, we suddenly get a substantial performance boost in detecting mood in music. And that points to how some of this data can actually have real-world implications and tools. The same kind of technique was also used in another context, in another project, to look at the different sizes and the clusters of musical emotion that arises from different languages. And a similar technique has also been applied in a production paradigm where there's the interaction between the creators and the raters in order to generate a naturalistic emotional stimuli, where the raters essentially choose which of their creation they think is most emotional. Then the creators would make more variations of this, and the raters choose again. And through this kind of selection pressure, you would increase the emotionality of the music. So some of these works have been recognized across different academic disciplines, from cognitive science to machine learning. And all of this is thanks to my most amazing supervisors that one could wish for. And yeah, I'm forever grateful to have received such academic support, but also personally for you being genuine friends. And equally incredible are my collaborators, where I really treasure the relationship and the research that we built together. And also I would like to thank all the funding bodies that funded some of my PhD, and especially the Max Planck Neurocom. And I would also like to thank my friends, families, and my girlfriend. And just most importantly, all of you really made this journey truly exciting and fun. And reflecting on how I started my PhD journey, I arrived to in-person Neurocom during COVID. And I gave my presentation interview talk. And I opened this talk with an old photo of mine. And I think I was trying to make the point that I'm interested in knowing how mine and others' musical experiences come from the experience and the cultural environment and how it's shaped over time. And I think throughout my PhD, with range of methods, now I have several answers to these questions. But at the same time, it gave birth to many more questions. And to this day, I still have the same, at the center of all this, I still have the same question that I started my PhD with. And I'll leave you with that. Thank you.